Humans have looked up at the night sky and wondered, are we alone? Enter the void. Many of us grew up thinking Earth simply revolves around the sun, and that the sun sits still, quietly holding us in orbit. But reality is far more fascinating and far more complex. Imagine that every motion we take for granted, day, night, seasons, is just a tiny part of a vast cosmic dance. Because as it turns out, Earth is not only orbiting the sun, it is also racing through the galaxy at an incredible speed, dragging our entire solar system along with it. And that motion may hold the key to some of the universe's greatest mysteries. Understanding motion. Think of yourself on an airplane, flying steadily at constant speed and altitude. Inside, you can't feel the motion. From your perspective, it's as if you are still and only the world outside moves. But to someone on the ground, the plane is clearly racing across the sky. This is the essence of Galilean relativity. There's no absolute reference point for motion. Observers can measure movement differently depending on their perspective. Now let's apply this to Earth. From our viewpoint, we see the sun rising and setting, the seasons changing. But on a cosmic scale, our perspective is just one of many. Choosing the right frame of reference is essential for understanding the true motion of our planet and the solar system. Earth and the solar system. At first glance, Earth's orbit around the sun seems simple, but it's not a perfect circle, it's an ellipse. Some days, Earth is closer to the sun, perihelion, around January 3rd. Other days, it's farthest, aphelion, around July 4th. And the planets don't just revolve passively, their gravity tugs on the sun itself. Massive gas giants like Jupiter and Saturn subtly shift Earth's orbit, a phenomenon known as orbital perturbation. Over thousands of years, these small shifts accumulate, changing Earth's climate in long cycles called Milankovitch cycles. These cycles influence the tilt of Earth's axis, the intensity of seasons, and even the timing of ice ages. In theory, a new ice age could begin tens of thousands of years from now, though human-induced climate change is currently disrupting these natural rhythms. Journey through the Milky Way. Earth's motion becomes even more mind-bending when we step out of the solar system. The Milky Way is a vast, spinning galaxy, a cosmic windmill of stars, gas, and dust stretching over 100,000 light-years. Our Sun, with Earth in tow, orbits the galactic center at roughly 143 miles per second, taking 230 million years to complete one full orbit. And it doesn't follow a perfect circle. It oscillates above and below the galactic plane, moving up and down once every 60 million years. This vertical oscillation may even influence mass extinctions on Earth. The galactic plane is dense with stars, radiation, and cosmic debris. A dangerous neighborhood. Our planet's rise and fall through this plane could expose us to increased cosmic radiation, potentially impacting evolution. Cosmic neighborhood. Earth isn't just carried by the sun. Every star in the galaxy is moving too. Their proper motion, the visible drift across the sky, changes the constellations over centuries. Even nearby stars shift subtly due to parallax, which astronomers use to measure distance. Our night sky is dynamic. The familiar patterns of Orion or the Big Dipper are temporary snapshots in a galaxy in motion. Local group and the Great Attractor. Zooming out further, the Milky Way isn't alone. It's part of the local group, a cluster of over 54 galaxies, including Andromeda. And this cluster is hurtling toward a mysterious cosmic mass called the Great Attractor, over 150 million light-years away. The local group races toward it at 373 miles per second, pulled by gravity from this unseen region. Our entire galactic neighborhood is in motion, not randomly, but as part of a grand cosmic ballet. Universal expansion. And beyond that, the universe itself is expanding. Galaxies are not moving through space in a traditional sense. Space itself is stretching, pushing galaxies apart at an accelerating rate. To measure our speed relative to the cosmos, astronomers use the cosmic microwave background, the leftover heat of the Big Bang. Relative to this frame, Earth and the solar system move at around 229 miles per second. We are quite literally surfing through the universe. Every second, every mile, we are part of a grand invisible motion across unimaginable distances. So, Earth is far from stationary. It orbits the sun orbits the Milky Way. The Milky Way moves toward the Great Attractor, and all of space itself expands around us. We are a tiny speck of dust in a colossal dynamic web of motion. Our orbit shapes our climate. Our galactic journey exposes us to cosmic rays, and the interplay of stars and galaxies defines the structure of the universe itself. Understanding Earth's place in this cosmic dance doesn't just satisfy curiosity. It connects us to the vast, elegant complexity of the cosmos. And it reminds us that while we may feel small, we are part of an extraordinary journey through space and time. If you're fascinated by how Earth and the universe move in this endless dance, make sure to subscribe and join me in the next exploration, because this journey is only just beginning.